So a degree is just from geometry. We know that one straight angle is 180 degrees, correct? A circle is, a rotation is 360. Some other review in geometry, if we start, this is called standard position starting here. If we go counterclockwise, that's positive degrees. And if we go clockwise, that's negative degrees. Okay. Just to be clear, when I'm talking about a revolution today, one revolution is one full turn around the circle. If I wanted to know what the distance traveled was for that one revolution, that would be the same as traveling around the circle. What do we call that? Circumference. So one revolution is a angular term. Its linear conversion would be that one revolution equals one circumference. Okay. Or pi times diameter, if you will. Radians. So let's talk about what a radian is. The definition of a radian is an angle of 1 radian is defined to be the angle at the center of a circle which spans an arc of equal length to the radius of that circle. Okay. So in first hour they were confused by what that meant. What that means is, let's say I made a circle and I made it have radius of, let's use centimeters, 1 centimeter. So there's my radius of 1 centimeter, and then I'm going to try the best I can. The circle would go around from there, right? Yeah. Can you not see? Okay. Alright, so there's a circle with I made a radius of 1 centimeter. Okay. What I'm saying is if I took like a piece of string and I measured that string 1 centimeter and I put it on the arc of this circle, so I measured 1 centimeter this way, if I completed that angle, that's the definition of what 1 radian is. That's what, by definition, what it is. One radian is the angle formed when the arc and the radius are equal. I picked 1, but it could be 2 and 2 and 4 and 4. When they are formed, that is the definition of what 1 radian is. What you need to know, because we've been thinking in degrees for a long time, is that pi radian is the same as 180 degrees. Okay. This works as a converter. If we want degrees, we multiply by 180 over pi. We want the degrees to be on top. But if we want radians, we multiply by pi over 180. You probably did some converting last year, a little bit. Okay? So we're going to do a little bit of that today. All right. So that's important to remember. Okay, so just to give you a point of reference here, guys, if pi radians is 180 degrees, let's just do some. What's pi over 2 the same as? 90. What's pi over 4 the same as? 45. Okay, let's keep thinking here. All right, so if 180 is pi, what do you think pi over 3 is? 60. And so, as we start to move along in this chapter, I'm hoping that you become fluid in those. That you're starting to read, okay, pi thirds is 60, pi fourths is 45. You're kind of going to have to always do that little conversion in your head, because we know 45. For a long, long time you've been doing degrees, right? Since you were in elementary school. Okay. Standard position for degree angles, revolutions, radians, blah, 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 is we start here, and we rotate in a positive direction. What happens is then we have something called a terminal side, and I'll show you what that means. It's where basically, if this was an arrow, it's where the arrow ends. Okay? So, pi halves. And we're not going to do the reference triangle for pi halves because pi halves is, we already know, how many degrees is it? Okay. But let me talk about what pi halves would be. So here's an xy axis. Okay, so if I moved here's my angle, and it's going to start down here on the x-axis. If I moved the tip of this in a counterclockwise direction, pi halves, it would end up here. This angle is pi halves radians. Okay, let's take a look at the next one. (11 pi 6). First of all, 11, let's talk about what pi 6 is. If pi is 180, what's pi 6? 30 degrees. So in our heads we're thinking every pi 6 is going to be 30 degrees, okay? Also, if 1 pi is 180, isn't 2 pi 360? Following? Okay. 11 pi 6, isn't that just a pi 6 shy of 12 pi 6? So here's what I'm going to do. I'm going to start in standard position. That's over here. I'm going to start rotating. Where am I at now? In radians? Pi over 2. Now where am I? Pi. Now I'm at 3 pi halves. Now I'm going to almost go to 2 pi, and I'm going to stop right here. I stopped. Pi 6 shy of 12 pi 6. That's where my angle ends. This whole distance around, this whole angle around, that was a revolution of 11 pi 6. So there's something called a reference triangle. A reference triangle is, when you do that, this forms a triangle with the x-axis. It forms this little triangle right here. Can somebody tell me that little triangle with the x-axis, if from here all the way around to here is 11 pi 6, what's this little angle in here? Just 1 pi 6, isn't it? 1 pi 6. That's what we call a reference angle. We're going to be using those a little later on when we do exact trig functions. All right. 4 pi thirds. Oh, let's see if we can figure this out. How many degrees is 4 pi thirds, do you think? Well, we know 1 pi thirds is 60. Couldn't we just multiply that by 4? If I want to, yeah, 240. Okay, so in our heads, let's draw our xy axis. Let's figure out this one. And here's where I'm going with this. Isn't 3/3 1? Isn't 4/3 1/3 past 3/3? Are you following that? So here's what I'm going to do. I'm going to start here. I am going to go all the way around to here. Do you agree I have now gone pi radians? Isn't that the same as 3 pi thirds? I'm going to go pi thirds past that. That's 60 degrees past that. So now I'm going to stop right here. From here, rotated around to there, is 4 pi thirds. Do you guys remember how far I went past the x-axis? I went pi thirds past the x-axis. So if I said, hey, what's the reference angle? The reference angle is just the angle made with the x-axis. This little angle in here is just pi thirds. Okay. Now, this one's a little tricky. This is where we have to remember, what is pi about? Like in numbers. 3.14. So if I asked you to go 2.9 radians, can you guys tell me at least kind of about how far you'd go? Well, wouldn't 3.14 be all the way to here? Okay. So wouldn't I be shy of that then? So let's first of all just convert it to see what, so I can show you a conversion. If I wanted to convert to degrees, I would multiply, because I want degrees, I would put degrees on top. So I'd multiply by 180 over pi. Okay, that makes sense then. 166, that's less than 180, correct? So we're going to start over here, and we're going to rotate, and we're going to end like over here. From here to here is 2.9 radians. Okay, guys, this is the tricky part. Let's find the reference angle, and the reference angle is this little angle made with the x-axis. How do you think I do that? Awesome. I'm glad you said not to convert it. He said just take pi minus 2.9, right? Because isn't that how far I'm shy of it? Okay. So pi minus 2.9 would be about 0.24 radians. So that would be my little reference angle in there, 0.24 radians. Okay, so that's a little bit of just introducing like what radians are equivalent to. Now let's convert, and we can do hard things, right? Can we multiply without our calculators? 2-digit multiplication? I always say if Charlie Comrie can do it, you can do it. He's in 5th grade. And I know they do 2-digit multiplication, and I know you're taking an SAT, and the more we do with non-calculator stuff, the better. So that's what we're going to do today. We are going to convert from degrees to radians, and we're going to reduce some fractions, okay? So, first of all, I have degrees. What do I want? Radians. So since I want radians, I am going to multiply by the radians on top, that's pi, over the degrees on the bottom. And then I'm going to reduce my fraction. Well, I don't care how many steps it takes you to reduce. If you have to reduce just by 2's every time, that's fine, but do you see they end in a 0? Aren't they both divisible by 10 then? Okay, cancel a 0 out top and bottom. Now, I have 20 pi over 18. What do those both reduce by? 2. Reduce them both by 2. Divide them both by 2. We have 10 pi over 9. That would be the exact radian measure of 200 degrees. All right, let's try the next one. This time I have radians. Let's convert to degrees. So, I want degrees. What should I multiply by? I want degrees, so I'm going to multiply and have the degrees on top by 180 degrees over pi. What's something really easy that cancels? Thank you, the pi's. All right. Then I'm going to try to reduce as much as I can until I have to do the multiplication. I notice that 8 and 180 are both even. Can we reduce them both by 2? Okay. I know you can do higher, but all right. So 7 times 90, what's 8 divided by 2? 4. Can't I reduce by 2 again? What's 90 divided by 2? 45. Okay, so now I have 7 times 45. 4 divided by 2 is 2. Okay, now this is where we do a little 1 by 2 digits. We can do this. 45 times 7. I know some of you can do it in your head. That's 35 carries a 3. 315. divided by 2. Okay. Let's see, well, 300 divided by 2 is 150. And 15 divided by 2 is what? 7.5. 157.5? Okay. Okay. So there's a little bit of converting then.